gas-like mantle? That's made out of thorium. Thorium is the 90th element, an actinide with 90 protons and 90 electrons with 142 neutrons. Thorium was discovered in 1829 by Jöns Jacob Berzelius with a density of 11.72 grams per centimeters cubed. Thorium has a melting point of 2023 degrees Kelvin and a boiling point of 5061 degrees Kelvin with an atomic weight of 232.0381 atomic mass units, and it was named after Thor. Thorium is a silvery white, soft, metal, somewhat similar to lead. It can be hammered, rolled, bent, cut, shaped, and welded rather easily. Its general physical properties are somewhat similar to those of lead. Thorium is a silvery white, soft, metal, somewhat similar to lead. It can be hammered, rolled, bent, cut, shaped, and welded rather easily. Its general physical properties are somewhat similar to those of lead. Chemical properties. Thorium is soluble in acids and reacts slowly with oxygen at room temperature. At higher temperatures, it reacts with oxygen more rapidly, forming thorium dioxide. Thorium is a relatively abundant element in the Earth's crust. Scientists estimate that the crust contains about 15 parts per million of the element. That fact is important from a commercial standpoint. It means that thorium is much more abundant than another important radioactive element, uranium. Uranium is used in nuclear reactors to generate electricity and in making nuclear weapons, atomic bombs. Scientists believe thorium can replace uranium for these purposes. With more thorium than uranium available, it would be cheaper to make electricity with thorium than uranium. The most common ores of thorium are thorite and monazite. Monazite is a relatively common form of beach sand. It can be found, among other places, on the beaches of Florida. This sand may contain up to 10% thorium. Uranium is one of the most important elements in the world today in the place of thorium. Why? One of its isotopes undergoes nuclear fission. Nuclear fission occurs when neutrons collide with the nucleus of a uranium atom. When that happens, the uranium nucleus splits apart. Enormous amounts of energy are released. That energy can be used for mass destruction in the form of atomic bombs, or used for peaceful energy production in nuclear power. Stay tuned for protactinium.